Okay. So remind me, where were we yesterday?
We were about to find A
And what did we
for,
know?
we knew B was 12,
Okay.
and um, we knew that C was 5.
Okay. And this is where we left off. And
Yes.
why do we need A?
Um, it makes the world go round, basically.
We cannot write the equation of an ellipse if we don't know three things. Can you tell me off the top of your head what they are?
A, B, and center.
Yeah, we need the center, which technically you're right, Sutter. That does kind of count as two things, I suppose. But we need the center, we need A, and we need B.
Oh, the center was
And there will be
2.
other things that we know along the way, but that's all just sort of information that we use to get what we really want. So just knowing that's going to get you a long ways through this. It's really a good like summative statement. I need the center, I need A, and I need B. So yeah, we have C. And remember, I think the reason that I knew we needed more notes today was because I wanted to talk to you. I want to take a little bit of a side trip here, and I want you to take this trip with me because this will help you, and you should write this down. I'm going to make a new page real quick, and we're going to take this equation and we're going to make three versions of it.
Okay.
I've gone back and forth on whether or not it's worth the time, and I think I've settled on it is. So what we want is to have a quicker sort of formulaic sort of approach to this. Like if I want to know the area of a circle, I plug in the radius to pi r squared, right? Like that's quick and easy. I would like something like that where I don't have to do math every time I want to solve. So let's say right now, if I want to find A, I want a quick formula for this. I want this to just say A equals. How would I solve this equation for A? Stick a root over the left side. Correct. So I could just, if I take this model, this formula up here, and I just square root the whole darn thing, and disagree with me if you want, it's fine. But we want to say that A is equal to the square root of C squared plus B squared.
Okay.
And what's nice about this is now that one's not very, it's almost not worth it. But what's nice is now if I want A, I've got just a quick one-stop shop formula to plug B and C into. Now, they get just a little bit more involved, but nothing that will even cause us, we'll barely even feel the bump in the road. Let's say we want to find B. So the way the formula is currently set up is I'd have to plug some stuff in, I'd have to move some stuff around. And again, I'd rather just have it set up and ready to go. So what I'd like is a quick one-stop shop formula for B. Let's think about B. If you were going to solve this like the granddaddy formula for B, what would you do?
Would be the
You would start by moving the C to the other side, right? So we know at some point in here, this is going to involve the A squared minus the C squared, right?
yeah.
But going back to what Sutter said, like we understand that to get B officially by himself, we have to square root away the exponent, right?
Mhm.
So our one-stop shop for B is B just equals the square root of A squared minus C squared.
Yes.
And just having these sitting around, again, you can be the judge. Do you think it's worth it or not? I don't know. But I want to do one more. And because now I want to have a one-stop shop formula for finding C. By the way, we will always know two of the three. So like the way this works is you're going to know A and C, or you're going to know B and C, or you're going to know A and B. Like, and if you know A and B, that's great news because you're ready to go. So what is my C formula going to be? What does C equal? Could you just read it to me? Right. At this level, I'm assuming you're not struggling to understand those mechanics, right? We move the B squared to the other side and then we square root the whole thing. So one of my objectives, which I didn't get to yesterday, was to get you this. And it's maybe over the course of the next week and a half while we do ellipses, maybe it saves you a total of 30 minutes. I don't even know. So maybe it's worth it, maybe it's not. So back then to the other page where we were working out to find A. What's our one-stop shop formula for finding A?
It is the root C squared plus B squared.
The square root of C squared plus B squared, which normally I wouldn't write that down. I would just do it, right? What's
Mhm.
C squared?
25.
25. What's b squared? Good. So we have the square root of 25 plus 1 photic bow. What's that?
169.
The square root of 169, which is, so we now know that A, thanks for that. So we now know that A is 13. Good. Okay. And so now did we ever know the
The
center
center
in this
was
problem?
x equals 2 and y equals 7.
So we did have a center.
Yeah.
So 2, 7 was the center.
Yes.
Great. So we have the center at 2, 7. And, at this point, only the things in red matter. Anything else along the way would have just been a means to an end. If you knew like the foci or a vertex or a covertex or the length of the major axis, that's all great and fine and good. But at the end of the day, it's just, can I get my hands on those three
Well, then
things?
we also have to know if it's a tall or wide.
Did we know that from
It's
the
a
picture yesterday?
it's a tall. Yes.
Thankfully, Zach wrote that down, I guess. So it was a tall one. Okay. Because this would have been like a delta math problem, right? That I was in the middle of, which no way am I getting that back. So according to Zach, it was a tall. So let's have faith in Zach. He wouldn't lie to us. So
Zach was indeed.
if it's a tall ellipse, what I need to remember about this when I'm picking the right kind of formula template to use is when I'm done, the bigger number. So we're going to have two big numbers on the bottom, our a squared and our b squared. Where's the bigger one going to go?
Uh, Underneath the one.
Underneath the y. Good. So remember, the orientation of the ellipse determines where the beefy number goes. And a is always the beefy. If you ever are doing this and a comes out smaller than b, then you done boo-booed because by definition, a is half the major axis. Got to be longer than b. What would we say if a and b were the same?
Same thing.
It's a circle. Like we wouldn't be having this conversation, right? So yes. All right. So our formula, our answer, our equation is going to be parentheses x what? Minus
X minus
2
2.
squared. And if you want to, I don't have any idea how you feel about this. Sometimes it's nice just to write that, get the vertex part out of the way. And then we got a couple beefy numbers coming up, right? What is b squared?
144.
144. What's a squared?
69.
And then you just got a choice. Where's Captain Beefy go?
Under the Y.
So 169 goes here, and 144 goes here.
It's actually kind of close to a circle or not.
It's very, yes. So we would say on that topic that this has very little eccentricity. So when something is more eccentric, then those foci are being pulled further and further apart. When you think about it, like a center of a circle is almost like the two foci are sitting on top of each other. It's not almost like that. It is like that. And then if those foci, like a couple of little dots were to split a little bit, then there's a little mild amount of eccentricity. You'd have a really almost circular ellipse. And that's kind of what we're up against here. But then as those foci get separated more and more, then that ellipse gets way more eccentric, right? So good observation on that. Yeah. Darn near a circle. How do you guys feel? Do you want to do another one like a delta math together like we did yesterday, or do you want to just get ripping on it? Completely up to you.
Grip it in.
You want to get in there and go? And if you have questions, you could say something like, can you pull up my screen? Because, with ClassWise, I can just put your screen up here and I can walk you through what's going on. I could do it
Yeah.
right with you. Sound good?
Yeah.
I say what I love about this assignment might be the very thing that you hate about it, and that's that it's not very repetitive. The Delta does a really good job. One problem is going to give you like a vertex and a covertex, and the next one it's going to give you like a focus and the length of the major axis. Like it's all over the place, and I love it for that. So I'm going to keep this paused. I'll pause it, and then like if you guys have questions, then I'll unpause it.